Hi, in this video we will look at how to use the Sslstrip tool. So in this demo environment what we've done is we've used VMware, and using this there are two virtual machines, one which is running Windows XP Professional, which is going to be the victim, and the other is Backtrack version 3, which is actually going to be the attacker machine. So before we actually begin with the real attack, let's actually look at exactly how the current scenario looks like. So let's say you want to check your mail on Gmail. Then when you click on Gmail and go to the Gmail website, what you will actually find is that the login page for Gmail actually has HTTPS on it, as we can see in the URL. And using this, it is very simple to understand that anything which is now going through this page will be SSL encrypted, right? So the HTTPS URL is there. Similarly, if we actually look at paypal.com, even if we type in paypal.com, which might be an HTTP reference, it automatically redirects to https.paypal.com, as we can see. And at the very same time, this form where one enters the username and password, if we look at the source, you will notice that the form submission is also via HTTPS. So let's actually scroll down. This is the form, and if we notice in the form action attribute, the URL is an HTTPS URL, which means that anything going to this URL will be sent over HTTPS and SSL. So with this small normal situation in mind, let's now go ahead and see how the security system can be compromised using the Sslstrip tool. So let's look at our IP address very quickly. The IP address is 192.168.1.6 and the gateway is 1.1. So this is the victim machine. Now what we will do is we will compromise this victim machine using a man-in-the-middle attack, and then look at exactly how the Sslstrip tool can be used. Let's also look at the ARP table, and if we notice the gateway ARP 192.168.1.1, the MAC address ends with F85A. So everything is normal right now. Let's now go to the Backtrack 3 VMware machine. So there are various steps before we begin the SSL attack using Sslstrip. The very first step is actually to put the Backtrack machine into IP forwarding mode. This is required because once the packets come, it is important to route them back to their final destination. So basically this entire attack consists of 4 steps. The first step is to put the attacker machine in IP forwarding mode so that it can forward all the victims' packets to the right address. The second step is actually going ahead and starting an ARP spoofing attack between the victim machine and the gateway, in which case what we do is we spoof the ARP replies telling the victim machine that the MAC address of the gateway is the attacker's MAC. The third step is actually setting up an IP table rule using which all the packets will go ahead and for port 80 would go ahead and be rerouted to port 10,000, on which Sslstrip is listening. And the final step is of course running Sslstrip. So let's now go ahead do these steps. So the next step, as we mentioned, is using the ARP spoof tool. ARP spoof, give it the interface name. The -T is actually the target, which is nothing but the victim, 192.168.1.6, and then finally the gateway for which we want to go ahead and spoof the replies. So as we can notice, the ARP spoofing using ARP replies has started. Let's go back to the Windows XP machine to verify this. Let's do an ARP -A, and okay, currently the gateway MAC is not there. Let's quickly just ping the gateway to see what is the MAC address registered. Let's do an ARP -A, and if we notice now 1.7, which is nothing but the attacker machine, which is the backtrack machine, and 1.1 both have the same MAC ending in 0F32, which is the attacker MAC. So the ARP spoofing is running successfully. Now the third step, as we mentioned, is to actually set an IP tables rule. And the reason for this is basically that we need to make sure that all of the victims' HTTP traffic is actually redirected to port number 10,000 of the attacker machine where the Sslstrip program is running. Right, so without getting into too much details of how IP tables work, let's run this command. Probably in a later tutorial I will cover IP tables in more detail. So once we run this command, the redirection is in place. Now let's run the Sslstrip tool. So we use the Python interpreter sslstrip.py -h to actually look at the possible options. The important one for us is actually the -w option, which is the name of the log file to log all the SSL posts, which is what happens by default. So we actually go ahead and give -w, and let's say the log file name is secret. So now the Sslstrip tool is running. Now let's go back to our victim Windows XP machine, and let's go ahead and fire up Internet Explorer. As we notice now, when we click on Gmail and the Gmail page loads, if you notice right now that instead of the regular HTTPS, we only see an HTTP. The reason for this is the SSL strip tool has actually replaced the HTTPS URL with HTTP, and that is what it sends back to the client. However, on the server side, it is still will communicate with the Gmail servers using SSL for whatever the victim sends it. Right, so let's now quickly try logging in and checking if one can steal the password. So I'll use a username called securitytube.net. It's a dummy username which I've created, and the password is securitytube_demo. Let's sign in. Well, we don't want to remember passwords. Okay, I think maybe I mistyped something. Sorry about that. Let's retype that. And as we can see, we managed to successfully log in. So what is happening in the background? Basically, what Sslstrip is doing is that it is changing all occurrences of HTTPS in the HTML page to HTTP, because of which all traffic going between the victim and the attacker running the Sslstrip tool is in plain text HTTP. Now in turn, the communication between the attacker and the final server, which in this case is Gmail servers, still happens over SSL. Now because the actual traffic between the attacker and the victim is in HTTP, there are no certificate errors or any other alarming messages which the user actually gets. For the user, everything is transparent. So now we are into the securitytube.net account. Let's go back to the attacker machine and see if we manage to nab the password. Let's quit the Sslstrip tool and let's look at the secret log file which we just created. And then let's quickly grep for securitytube, which is the name of the username. Security tube, yes. So we can see that there are a couple of occurrences. Let's scroll down. Right now there is no password here. Securitytube.net is the username. Okay, now we are here. If we notice in this post request, the password is available. Password, as we can clearly see, is securitytube demo, and the email name is securitytube.net. So as we can clearly see, the Sslstrip tool has managed to capture my password in transit, yet without ever making me feel in any way that there was something malicious going on. So let's run the tool again, go back to the victim machine, and now let's look at what's happened, let's say on another website, PayPal, which we had a look at in the beginning. So when we type in paypal.com, it should now, as previously when tool was not running, should ideally have redirected to https.paypal.com. But as we can see in this case, the redirection has happened still to http.paypal.com, right? Which we can clearly see is what Sslstrip tool has done in between. Let's now view the source and go back to the login form part of the code. And as we notice, now the form action is HTTP and not HTTPS, right? And this is something, once again, the Sslstrip tool has changed in transit. Well, so I think that's all for this video. Basically what we've done is we've demonstrated how the Sslstrip tool can easily fool a user into believing that he's actually logged into an SSL enabled website while still being on the unprotected HTTP traffic. Well, I hope you enjoyed this video. It would be very nice if you could leave a comment in the leave a comment section just below this video. Have fun using the Sslstrip tool. That's all. Thank you.